anything that reaches a maximum or minimum, any kind of problem, can be modeled with a quadratic function. Okay. Anything that is thrown always takes a parabolic shape. In other words, the shape of a parabola. Okay. So let's take an example. Here we have a diver. Okay. So a diver's height, actually the path that they take on a dive, can be modeled by a quadratic function. And you can see, we'll get to this in a bit, but this would be a model of this person's dive. And you can see that they climb up, reach peak, and then hit the water and go a little bit below before coming down to the surface. Okay? So the equation that we use, and this is really, remember we used this notation last year to represent function. We could also just call this plain old h. Okay? And it's negative 4.9 t squared plus 6t plus 3. What form is that? What form is that function in? You got a choice of two. Standard form. Good. Yeah. And how do I know by the equation that the diver's reaching a maximum and then coming back down? Look at the equation. What tells me in the equation that the diver's going to reach a maximum? The negative, right? Because the negative always takes an upside down shape of a parabola. Okay, so here's a couple of questions we can answer from this. First of all, we're going to find the y-intercept, or really in this case, because we've replaced x with time and y with height, we're really finding the h-intercept. Well, how do you find the y-intercept of any function? What do you do? Make x 0, or in this case, t equals 0, and then just calculate. So h will be negative 4.9 times 0 squared plus 6 times 0 plus 3, which gives me 3. What are the units? We've got time is x, which is in seconds, and we've got height, which is in meters. So what does that point represent? Like, what does it actually mean in terms of this dive?
Like where the diver is starting?
Right, exactly. Where the diver is starting, 3-meter platform or 3-meter springboard. So this represents the starting height of the diver. Okay. So that's one piece of information we can get from this problem. Another piece of information, we can find the vertex. Well, you already told me this is in standard form, so how do I find the vertex? There's two ways we could do it. One might be a little bit complicated in this case. The other might be better.
The negative, like the x vertex, negative 3 and 2.
Right. So the x vertex, or because we're in a problem, the t vertex is going to be negative v over 2a. Well, what's v? 6. So negative 6 over 2 times negative 4.9. And let's round that to 3 decimal places. Everybody got it? Three decimal places. 0.612. Thank you. And how do I find the Y vertex, or in this case, the H vertex? Yes, plug this back in for T and calculate. When you do that, you will get, or you should get, about negative 1.835 for this, plus 3.672, plus 3, which is going to be approximately, if we go to 3 decimal places, 4.837. Well, that's great. But what do these actual numbers mean in the problem?
For X and Y.
Yes, at the
Maximum.
maximum. So it takes 0.612 seconds for this diver to reach a maximum height of 4.837 meters. That's how you would interpret it. Okay? So it takes the diver not very long, 0.612 seconds to reach a maximum height of 4.837 meters. So you see, now we can actually interpret these things. So like we looked at briefly, here's a visual representation of the dive. And we can include the numbers that we found. So here, what's the H-intercept? Of 3. So the diver launching off the diving board goes up, takes how long to get from here to here? 0.612, and then notice almost at a height of 5 meters or 4.837. So this is the vertex. This is another interesting point that we're going to talk about actually in the next unit. But for now, we're going to estimate it because this would be the x-intercept or the t-intercept in this case, because we replaced x with t. And so answering the question here, approximately how long did it take the diver to hit the water after starting? What is this approximately along the t-axis? 1.6, sure. Yeah, that's fine. Something else that we haven't really talked too much about, a little bit, but we can also find domain and range of this situation, but it would be a restricted domain, because normally in a parabola, you guys would say, oh, the domain is everything, negative infinity to positive infinity, and the range is negative infinity all the way up to the height of the dive. But this is a restricted situation. The start is here, and we'll assume the end is here. We won't count going below. So what would the domain be of from here to here? 0 to 1.6. So we're restricting the domain this time because it's an actual situation. We're not just looking at a general parabola. And what would the range be?
0 to 4.837.
Yeah. 0 to 4.837. Good. Okay. So there's a situation where you're given the quadratic function and it actually models a situation. So you can answer questions like this, but then in the next lesson to finish this off, you may also have to construct the quadratic function. You may have to make it, given the information in the problem. Not may, you will. Okay? So